We've all seen the memes, the long threads, and the heated debates. The flat earth theory isn't just a fringe idea anymore. It's a global conversation. Most people try to debunk it with photos from space or the curve of the horizon. But there is one undeniable geometric fact that ends the debate instantly, and it has nothing to do with NASA. Today, we're putting the flat earth to rest using the simplest math imaginable. One of the biggest questions flat earthers ask is, if the earth is a ball, why can I see things that should be behind the curve? It's a fair question, but it ignores a fundamental law of perspective on a sphere. On a flat plane, you could technically see a massive light source from any distance if you had a powerful enough telescope. But on Earth, no matter how powerful your lens is, stars below the equator disappear as you move north, not because they're too far, but because the physical ground you're standing on is rising up to block them. Here is the one mathematical fact that ends the debate. The three-right angle, triangle. In a flat world, geometry is absolute. If you draw any triangle on a flat map, the three internal angles must always add up to exactly 180 degrees. It is a fundamental law of a flat plane. But on our Earth, you can do something impossible on a flat surface. Imagine starting at the North Pole and traveling in a straight line down to the equator. There, you make a perfect 90-degree turn and travel along the equator for a few thousand miles. Then you make another perfect 90-degree turn and head straight back to the North Pole. When you arrive back at the start, you will find you have completed a triangle with three 90-degree angles. That's 270 degrees. This is called spherical excess. It is physically and mathematically impossible for a triangle to exceed 180 degrees unless the surface it is drawn on is curved. This isn't a theory or a NASA photo. It is a geometric reality that pilots, sea captains, and surveyors have used for centuries to navigate the world. On a flat Earth, your flight would miss its destination by thousands of miles. On a globe, the math is perfect. Then there's gravity. In a flat Earth model, the disk would have to be accelerating upward constantly at 9.8 meters per second to simulate gravity. But if that were true, the energy required would be infinite. On a globe, gravity pulls toward the center of mass. This is why the oceans stay down and the atmosphere doesn't drift away. If the Earth were a disk, gravity would pull you toward the center of the disk, meaning the further you walked toward the edge, the more it would feel like you were climbing a steep, vertical mountain. The debate is fascinating because it challenges us to prove what we take for granted. But when you look at the geometry of a triangle or the behavior of the stars, the flat plane simply falls apart. The truth isn't hidden in a conspiracy. It's written in the very math of the world we walk on. So, is the debate finally over for you? Or is there one proof you still can't explain? Let's settle it in the comments.